We're going to start discussing life cycle assessment. It is very important to understand this method because it's the baseline for many other methods that have been developed in industry with some modifications, particularly for construction industry. So to start understanding the assessment method, we have to come back to start reviewing or going back to life cycles thinking. So the life cycle assessment is the quantification of the impacts based on life cycle thinking. So we're gonna start thinking about a product or an activity, any activity that we can think of, and we're going to start analyzing the when did it start this activity or when did it start this product. So it comes usually from the extraction of the materials and then the manufacturing of this material, then the distribution, and then the use. But the story doesn't stop at the use. So now we have to think about the disposal or the recycling, and we also need to now pull the concept of circular economy to try to bring again the material or the things that are useful or that can be go back into the cycle. So life cycle assessment consists of 4 steps, and this is a standard. It goes from goal and scope definition, and this is where we decide what is the goal of doing this assessment. And it can be many. It can be, for instance, comparisons with better options, or it can also be just for assessing environmental impacts or proving the sustainability of an activity or a product. Then the second activity is the compilation of life cycle inventory. So in an inventory, we're going to put all the components of this product or activity, and we're going to assess the emissions. We can put, for instance, a consumption of fuel due to transportation of material, or the components that are required, the inventory of the components that are required to build that material or to operate in the case of we're talking about an activity, right? The third step is the impact assessment. So the impact assessment is how are we going to define whether something is sustainable or not. So a way of assessing is in terms of kilograms of CO2 equivalents or CO2 emissions, but we say CO2 equivalents because it can be other greenhouse gases that are also affecting global warming. And then we also have acidification, and this is acidification is assessed in terms of kilograms of sulfate equivalent. And we can also have other impacts, like based on toxicology or toxicity impacts. The fourth step is the comparison of the activity or the process against things that can be improved or can be changed. And this is the area where we can look at also sensitivity of the inputs and outputs. So see how impactful they are if we vary them. And also we will also have to discuss uncertainty, because we may not be able to cover everything on our assessment, and we also need to point these aspects. So since this method has been developed for already a significant number of years, there are many databases already. So, and also there are programs available for making this LCA analysis. This is just an example of two that are the most popular ones. That is the EcoInvent database and also the CIMAPro software, where that it also contains a database. If we don't have, we can also do a life cycle analysis, like life cycle assessment analysis, by looking at by making the inventory of the things that we want to put or include, and then looking at the literature, and looking at the estimation of the quantities, and also estimation of the impacts based on already reviewed material. So let's look at this example of milk production to have an idea of how complex a life cycle assessment can be, and also to understand all the components that we need to consider or we may have to consider, and also a way of defining later on the boundaries of the system. So to produce milk, we need cows, and these cows need to be fed. So they can be fed with soybean, which is a very popular way of feeding livestock. And then these soybeans may not come from the same area, or may not be produced in the same area where the cows are being grown. So we will need transportation of this feedstock, right? And then we also need to consider the energy that is being required to run this fabric, or this place where the milk is extracted from the cows. For this area, we may also need fertilizer, or we may need other inputs to the system to maintain the, the, the livestock. So we have many options here, because we may have options on where are the crops that are used for feeding, where is the source, and what is the impact of bringing the food for the cows from overseas as compared to producing it on the same place, etc. And then we also have a dairy plant that needs to be run, and then we need to transport this dairy to the supermarket, and then to finally it gets to the consumer. And then you need to think about what are the impacts that we want to look at. So this example can help us to see all the areas or the steps that we are considering on our life cycle assessment. This is when we consider all the areas from extraction till the end of life management. We say that we are consider the system from cradle to grave. And when we only consider extraction and material and production, we will say that we are considered from cradle to gate. And if we are just consider one of the sections of this overall process, we will say that it is from gate to gate, our system boundary. All right. So these are there can be other steps in between, but this is a general overview of all the phases of the process that we need to consider in our LCA analysis. So another way of seeing this is the way that we've been discussing when we were talking about life cycle thinking, right? So these are the steps, and generally speaking, users of this method divide the system into production, construction, use, and end of use or end of service. And in this figure, what we can see is some of the things that need to be considered on each step of this process. So we just discussed what is called system boundaries. So we need to, when we define goals and the scope in our LCA analysis, we need to say what are the boundaries of our system and that we are analyzing. Now we need to discuss the impact that we are assessing. And this can be, as I mentioned to you, global warming or acidification, but we can also have ozone depletion, eutrophication, etc. When we are when we define the impact category, this is what is called a midpoint. When we talk about a damage category, this is what is called the endpoint. To get the impacts, we need to find what are the indicators of this impact. So for instance, if we're talking about acidification potential, it means that the units will be sulfate equivalents, and the substance that we need to look at in our system are sulfate, NOx, and other type of acids such as chlorhydric acid. If we're talking about eutrophication potential, we are going to need to have the units of nitrogen equivalents, and then we will have to consider phosphorus and nitrogen compounds because these are the ones associated to eutrophication. In the case of global warming potential, the units are CO2 equivalents, and CO2 equivalents are all the greenhouse gases. And we already have a table where we have the equivalent of CO2 equivalents of these gases, so we can do the conversions, appropriate conversions. Then we need to talk about the functional unit. So the functional unit is the normalization of our results based on one unit. So we can talk about the life cycle assessment of the transportation, and we're going to look at the impact of greenhouse gas emissions, and the functional unit can be per passenger. So this per passenger will be our functional unit, and everything will be what is called normalized based on units per passenger. This is very important because if we think about transportation, the implications of CO2 emissions due to transportation by plane or by car or by train must have this functional unit in order to be able to compare, right, the impacts. So functional units can vary depending on what are we looking at. So in the case of the meat or the patties to make burgers, the functional unit can be protein. So everything will be based per gram of protein. So we know that is the thing that is in common for the beef burger and the plant-based burger. And then, well, as an example, we can show that the plant-based burgers consume less water, land, and produce way much less greenhouse gas emissions and consumes less energy. On the other hand, we may want to have our functional unit in terms of per capita, and this is an example of footprints by diet type, and this is the impact is again greenhouse gas emissions or global warming, and this is an equivalence of CO2 per person, tons of CO2 equivalent per person. And then we have as foods that are compared, the meat lover burger, this information is from the USA, and the average burger, the no beef burger, the vegetarian burger, and the vegan burger. So look at this comparison and look at the example when we are talking about in terms of protein, when we see that the difference in terms of water consumption and other impacts are very dramatic. And look at this now when we normalize in terms of per person, right? These things look slightly different. So the emissions, the CO2, when we're talking about CO2 emissions, and when we're talking about global warming, in terms of materials, we can also find the amount of CO2 that is being emitted due to the production of certain materials. and the functional unit in this case can be per kilogram or per cubic meter. We can use these tables for assessing what would be the impact of using these materials depending on the amount on a building. So once we have decided the system boundary, the midpoint and the endpoint, or the impact, and also the functional unit, we can start developing the life cycle inventory. So the life cycle inventory is the stage that involves data collection and further calculations relevant to inputs and outputs that describes the system under assessment. To develop this inventory, it's a good idea to have a flow model of the technical system and where we put the inputs and the outputs. So inputs can be energy, water, or raw materials, for example, and the outputs can be the water effluents, the air emissions, solid wastes, products, and the economic cost as well. Even that can be considered. So once we have this inventory analysis, we can translate this table to the units of the impact that we have selected. So we need to convert these to total, for instance, CO2 equivalents, or we can say a total amount of water that is being used. And now we can have the interpretation of the results, and we can start on the interpretation of the results, we can start having some sensitivity analysis. So this is the area where you will have to start using systems thinking to consider different scenarios. So this is where you're going to consider the options of taking one pathway or another for making use of the products, or for disposal of these products, or having options for recycling, or for using different technologies that may help to reduce the impact that you're assessing. So what is a sensitivity analysis? A sensitivity analysis is the identification of data elements that contribute significantly to each impact category.